The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, or email me at bmayo@ybcc.edu and I'll respond as soon as I can. Okay, so we're going to go on and look at section 8.4. which is solving compound inequalities. All right. So I have a question. Let's say that this is Nob Hill Boulevard, and this is 16th Avenue. Okay, what is that? Anybody? The part that's marked in. What do you call this piece right here? Where 16th Avenue and Nob Hill Boulevard overlap. What is that referred to as? Cat's got your tongue, fine. Okay, this is called the intersection, right? That's the intersection. Now, is that part of 16th Avenue? Yes. Is it part of Nob Hill Boulevard? Yes. So the intersection of 16th Avenue and Nob Hill Boulevard is the piece that is in both of them, here comes the big word, simultaneously, okay? So where two things overlap, that's where they intersect. All right, now, what if I were to pave all of Nob Hill Boulevard and all of 16th Avenue? So I'm going to pave all of this, and I'm going to pave all of that. Would I pave this part here twice? No, I wouldn't, would I? But if I were to pave all of it, I'd pave all of this along with all of that. That would be called the union. So the intersection is what two things have in common, or they share the same thing. And the union would be all of both things. Okay, let's go further with this idea. Let's say we have the following sets. We're going to let A equal the set containing the elements or numbers 0, 1, 2, 3, 4, 5, and 6. Okay? And B is going to be the set. Oh, I never could make those things. The secret is to go slow. There we go. B contains 4, 6, 8, and 10. Set C contains the elements or numbers -3, -1, 0, 1, and 2. And set D contains the elements -3, 1, 2, 5, and 8. All right, so we've got sets A, B, C, and D. Now, let's go back here for a minute. The symbol for union in this context is a U without the tail. The symbol for intersection is an upside down U. All right. So now I want to find A intersect B. That is to say, what numbers are in the intersection of A and B. What do A and B have in common? So as we look across at those different sets, we see that they both contain 4 and 6. Everybody see that? So the intersection of A and B would be the numbers 4 and 6. That's what those two sets have in common. Any questions there? All right, let's take a look at the union of A and B. So that's everything in A along with everything in B, and I'm going to list them in numerical order. So let's see, I've got 0, 1, 2, 3, 4. 4 is in both of them, but I only have to list it once. 5, 6 is in both of them. I only have to list it once. Oh, and then 8 and 10. So there is the union of A and B. Everything in A along with everything in B. Okay? How about the intersection of A and D? What's in A that's also in D? 1, 2, and 5. Again, everybody seeing this all right? Okay. What about the intersection of B and C? Oh, they have nothing in common. B and C have nothing in common. There are two ways we can list this. This symbol is called the null set. It means there's nothing in the answer. Now, I've had students in the past that were in the military that use this as a 0, but in mathematics, a 0 is just like this, and this symbol means no solution or the null set, okay? There is another way we can say this, and that is we can draw a set with nothing in it, or called the empty set. So this means no solution, this means no solution. Don't do this, however, because if you put the symbol for the null set inside this set, it's no longer an empty set, and that's confusing. So one or the other, okay? I find it easier to make this than that, so that's what I tend to use. But they basically mean that sets B and C have nothing in common. All right. How about the union of A and C? So A and C, we want everything in A along with everything in C. So -3, -1, 0, 1, 2, 3, 4, 5, and 6. All right. Any question about these? Okay, we're going to move on to some different kinds of problems, but dealing with the same thing. Now, intersection, the symbol is an upside down U. Union, the symbol is a U in certain contexts. In other contexts, intersection has the word and union has the word or. Okay, let's say we've got two sets. The union would be everything that's in this one or that one, because if it's in either one, it's in the union. Okay, intersection, it has to be in this one and in that one to be in the intersection. They have to have those in common. All right. When my wife and I got married, we each had some vinyl record collections. For those of you that are like, what's that? That's those round black things with a little hole in the middle and a bunch of, yeah, whatever, okay. And I had the following. I had, let's see, what did I have? I had a Grand Funk Railroad, and I had the best of the Guess Who, and I had, let's see, the Archers, anyway, a bunch of others. But so this was mine. This was my record collection. Sue had Barry Manilow. I'm not sure if I spelled that right. My apologies if I didn't. And she had Star Wars. And she also had the best of the guess who. Now, what was the intersection of our record collection? The best of the guess who. We both had that album, so we could take one and sell it at a yard sale or something, okay? What was the union of our record collections? Well, we had Grand Funk Railroad, the best of the guess who, the Archers, Barry Manilow, and Star Wars, okay? So intersection, what you have in common, union, all of mine along with all of hers, okay? We have a saying at my house, because her name is Sue, we say, mi casa es Sue's casa es Sue's casa. That's my limited Spanish. Okay, anyway. Now, we have the following two inequality statements. X is greater than -2, and X is less than or equal to 5. These are what are known as a compound inequality. It says solve each compound inequality, graph the solution set if one exists, so we're going to be graphing on a number line, and write it using interval notation. So we've got a compound inequality. There's two different inequalities there. It says and, so we're looking for the intersection where they overlap. We're going to find the solution, we're going to graph it, and we're going to write it in interval notation. Okay, now, my experience has been that it's helpful to graph the individual pieces in order to see what the solution is. So I'm going to start out by graphing X greater than -2, okay? So on a number line, I would have parentheses at -2 with an arrow going to the right. The parentheses means I do not include -2, but the arrow going to the right says it includes everything larger than -2, okay? Then I'm going to graph X is less than or equal to 5. 1, 2, 3, 4, 5. X is less than or equal to 5. So because it includes 5, I'm going to have a bracket at 5 and the arrow going to the left. Okay, so X greater than -2 includes everything greater than -2 on up to infinity. X less than or equal to 5 includes everything from -infinity up to and including 5. But I want the intersection. So I want the values of X that are in both inequalities. Okay, now keep in mind this thing continues on and this thing continues on. So where do they overlap? Well, starting right after -2 and going up to and including 5. So that is the graph of the solution. Everything between -2 and 5, not including -2, but yes, including 5, all of those points are in both of those inequalities. That's where they intersect. Now, how would we write that in interval notation? So that's X goes from -2 to 5. The parenthesis means it's open. It doesn't include -2. The bracket means it's closed at that end. It does include the 5. Okay. So this is interval notation. And this is the graph. Okay. Any questions on that? All right. Let's take a look at another example. Let's see here. 5x minus 3 greater than or equal to 2, and 6 greater than or equal to 4x minus 3. Now, for the first set of inequalities, they were already both solved for x. In this case, they aren't. So the first thing we need to do is solve each one. So 5x minus 3 greater than or equal to 2, we're going to solve this for x on the left side of the equation, or of the inequality, excuse me. So we're going to add 3 to both sides, which gives us 5x greater than or equal to 5. We'll divide both sides by 5, so x is greater than or equal to 1. So we solve that inequality for x on the left side of the inequality. All right. The second inequality, going to solve for x. Let's see, but I want it on the left side. So here's what I'm going to do. I'm going to add 3. I'm going to say 9 is greater than or equal to 4x. I'm going to divide by 4. So 9/4 is greater than or equal to, whoops, greater than or equal to just plain old x. Now, I said I wanted to solve it for x on the left. Let me ask you this, okay? Let's see. Is there somebody there that's willing to share their age, and they can lie about it? You can just say that you're a certain age. Just somebody say, I'm so-and-so years old. Anybody? Again, you don't have to tell. You can call yourself whatever you want, okay? Jamie, can we say that you're 30? You okay with that?
Yes, yes,
Okay,
sure.
great. Okay, so I am 63. Now, you'd be amazed at that I'm that old. That's because when you're 63, but you act like you're 12, people think you're younger. So if I'm 63 and you're 30, we could say that Ben is older than Jamie, right? That's from my viewpoint. But from Jamie's viewpoint, she would say Jamie is younger than Ben. So saying Ben is older than Jamie is the same thing as saying Jamie is younger than Ben, okay? Different viewpoints, but still true, okay? So like, for instance, 3 is greater than 2, but 2 is less than 3. All right, what about all that? So what I'm gonna do is I'm gonna take this and I'm gonna turn it around so that x is on the left. So instead of saying 9/4 is greater than or equal to x, x is less than or equal to 9/4. It's important with an inequality to have the variable on the left, because when you go to interpret it, if it's on the right, people tend to mess it up. Okay, so here is the information I'm going to use. Okay, I've solved each inequality separately, and I have them so that the variable is on the left side of the inequality. I'm going to recopy that information on the next page so I have more room to work with. So I've got x greater than or equal to 1 and x less than or equal to 9/4. Okay? So now it's just like the first problem was, but I had to solve the inequalities first. So I'm going to graph x greater than or equal to 1. Let's see here. So greater than or equal to 1, we'd have a bracket at 1 with an arrow going to the right. X less than or equal to 9/4. Let's see, 1, 2, 3. 9/4 as a mixed number would be 2 1/4. So that's right about, let's see if that's a half. So right about there. Okay, so that's 9/4. I've got a bracket there and an arrow going to the left. All right, 9/4, 9 divided by 4, 2 1/4. And intersection, where do they intersect? They intersect from 1 up to 9/4. So the graph would be bracket there. Let's see. Bracket there. Filled in. Interval notation would be from 1 to 9/4. Okay. Now, a couple of things to remind you of. In WebAssign, don't use mixed numbers. Okay. You could use a decimal, so you could use 2.25, but don't use 2 1/4 because it doesn't work well. For whatever reason, mixed numbers don't get, yeah, just avoid them. Okay. All right. Another thing in WebAssign, sometimes the scale is a little tricky. And what I've noticed is that if you're really close where you line things up, it takes it as being correct. But if you're off a ways, it takes it as being incorrect. But sometimes it'll give you problems where the scale is in tens and you're supposed to graph a 7. And so you kind of have to eyeball it. So just be careful with that. Okay. Get used to that. All right. You okay with this example? So now let's take a look at another one. This is, let's see here, x plus 2 less than -1/3 x and -6x less than 9x. All right, so again, I want to solve this thing. I want to solve each inequality separately first. I want it with x on the left. So for the first inequality, I'm going to add 1/3 x to both sides. That's going to give me 1 1/3 x plus 2 less than 0. Okay, but remember I said I want to avoid mixed numbers. So 1 1/3 would be 4/3 x. Are we okay with how I got there? If not, say so and I'll walk through it. Okay, subtracting 2 from both sides, 4/3 x less than -2. Now, I've got x on the left, but I need to get rid of that 4/3 coefficient. When you have a coefficient that's a fraction, rather than dividing by it, you multiply both sides by its reciprocal. Remember that? So these reduce down to 1x, and over here, -6/4 reduces down to -3/2. Okay, so solving the first inequality, I've got x less than -3/2. Okay. Second inequality, I'm going to subtract 9x from both sides, -15x less than 0. Divide both sides by -15. Do you remember what you do to an inequality statement when you either multiply or divide both sides by a negative number? This should have come out back in the very first stuff we looked at, 3.7 and 4.5. When you multiply or divide both sides by a negative number, you change the direction of the inequality. Don't forget that. Okay, let me say that one more time. When you multiply or divide both sides of an inequality by a negative number, you change the direction of the inequality symbol. All right, so this is x greater than 0. And we'll bring down the and. So we've solved each inequality separately. So now let's go on and find the intersection. And I'm going to recopy that on the next page again. X less than -3/2 and x greater than 0. Okay, so x less than -3/2. Let's see, we've got 0, -1, -2. -3/2 would be what? Halfway between -1 and -2. So it's going to be parentheses with an arrow going to the left. It doesn't have a bracket because it's not including the -3/2. Then x greater than 0. Looks like that. So what's the intersection of these two? What do they have in common? Exactly. Okay, so no solution, no graph, nada, zip, zilch. All right, we're good to go. All right. So those were examples of intersections. It was an inequality and another inequality. That word "and" translates into intersection, where the two overlap. If they don't overlap, there's no solution. Now we're going to look at something called a double inequality. There are three parts to this inequality. There's the left end, the right end, and the middle. We want to solve for the variable in the middle. Because there are three parts, anything we do to one part, we must do to all three. To get x by itself in the middle, I need to subtract 3 from the middle. So I'm also going to subtract 3 from the left and the right ends as well. 4 minus 3 is 1, less than or equal to x, less than or equal to 4. Okay? Any questions about that? So I'm going to graph that. Now, the way you read this is you read it from the middle. So I could say 1 is less than or equal to x and x is less than or equal to 4. But from x's perspective, can you see that x is greater than or equal to 1 and it's less than or equal to 4? So on my graph, I'm going to have a bracket at 1 and a bracket at 4 and this filled in. Which reminds me of another thing back in WebAssign when you're graphing these inequalities. Look at the menu. There's ways to click on the bracket and the parentheses and the arrows and all that. So be careful with it. Make sure you learn how to get used to that. Okay. How would that look in interval notation? Like that. Everything between 1 and 4 inclusive. Any questions about this example? Okay, let's see now. There's one I want to do. I can find it. Here we go. Okay. Here's another double inequality, okay? So again, the goal here is to get x in the middle. Inside, on the middle, I have a denominator of a 3. So to get rid of that, what I'm going to do is I'm going to multiply each of the 3 pieces by 3. On the left side, 3 times 0 is 0. In the middle, the 3 outside and the 3 in the denominator reduce out, and 3 times 2 is 6, okay? Now, I did not multiply or divide by a negative number, so I have no reason yet to change the direction of the inequality signs, all right? Next thing I'm going to do is I'm going to subtract 4 from all 3 pieces, so I get negative 4 less than or equal to negative x, less than or equal to 2. But now I have negative x in the middle. It has a coefficient of a negative 1. So I'm going to divide each piece by negative 1. But remember, if you multiply or divide both sides of an inequality by a negative number, you have to change the direction of the inequality symbol, or in this case, symbols. So this becomes 4 greater than or equal to x greater than or equal to negative 2. Now, the problem with this answer is that the statement now goes from largest to smallest, and we always want it to go from smallest to largest, going from left to right. So I'm going to take this and I'm going to change its viewpoint. I'm not going to change the directions of the signs. I'm going to change the whole thing. So it's going to look like this. Okay. Are we all right with that? So here, because I divided by a negative, I did change the direction of the signs. But from here to here, I just turned it around to write it from smallest to largest. Okay. Now, what would the graph of that look like? Let's see here. It's going to be between and including -2 and 4. And interval notation would look like that. Okay. Let's see here. Trying to find that 4 minus x. Okay. All right. You okay with that? There was a lot going on in that problem. All right. So we've dealt with intersection and we've dealt with double inequalities. Now we're going to deal with or union. Let's see here. -2 or x greater than 6. Okay. So both of these are already solved. So I don't have to do that first step. I'm going to graph each one of them. So x is less than or equal to -2 would look like that. X greater than 6 would look like that. Okay. All right, now I want to talk about the state of Hawaii. But first, let's talk about Idaho, okay? The state of, it's more fun to talk about Hawaii, but Idaho is landlocked. It's one big chunk of land, right? If you look at on a map, all of the parts of Idaho are connected there. There's no, parts that are separated by water. There's no islands or anything, at least not that I know of, okay? So that's the state of Idaho. It's one mass of land, okay? But now let's talk about Hawaii. Hawaii is made up of several different islands that are separated geographically by water, okay? There's the Big Island, and then there's Oahu and Maui, and I can't remember the other ones and everything. But the point is, when we talk about Hawaii, we have several different separated land masses, okay? What does that have to do with anything? Well, this example that we're looking at here, the word or means union. But these two pieces are geographically separated. So when I go to graph the union, we're going to have that piece and that piece on the same graph. When I go to write it in interval notation, I can't write it as a single interval. It's going to look like that, because there's one chunk that's -infinity up to including -2, and another chunk that's 6 to infinity, not including 6. So just like Hawaii has more than one geographic chunk of land, when we take the union, they're still separate pieces. So we would have to write interval notation like that. Okay? All righty. Let's see here. Let's take a look at this one. 2x greater than x plus 3, or x over 8 plus 1 less than 13/8. All right, so first thing I want to do is I want to solve each separate inequality for x with x on the left side of the inequality. So the first one, I'm going to subtract x from both sides, and I get x greater than 3. Okay. The second one, I have a couple of fractions, the least common denominator of which is 8. So what I'm going to do is I'm going to multiply both sides of the inequality by 8. So I'm going to get 8x over 8, which is x, 8 times 1, which is 8, 13/8 times 8, which is 13. Okay. Everybody okay with what I just did there? 8 times x over 8, the 8's is reduced down, the 8's reduced down, and we have x. 8 times 1 is 8. 13/8 times 8, the 8's reduced down, and we have 13. Come back and subtract 8, I get x less than 5. And here's the or situation. So let's write this all on the same line. Okay? So I've solved each inequality for x on the left. Okay? It looks like a 4, but it's supposed to be an x. So let's graph these two things. Let's see here. X greater than 3 would look like that. X less than 5 would look like that. Or the union. If we take all of the first one along with all of the second one, we put them together, what do we get? We get all real numbers. Not much better, but okay. So the union of these two, that's like that marriage made in heaven. Between the two of them, they had it all. Okay. So if we take all of this as well as all of that, notice I carefully avoid using the word and. Okay, we take all of both of them, take their union. Between the two of them, they've got all real numbers. Okay. Now what's that? How is that different from this one? Well, this one, it was a bunch of stuff going that way and a bunch of stuff going that way, and there was this gap in the middle. There was that water between the two islands. But here, they overlap, so between the two of them, they've got it all. All right with that? Okay, here. Let's take a look at some more examples. I know what I want to do. So I think the author introduces these problems because they want you to, again, be working with function notation. So this says -6 less than f of x less than or equal to 0, where f of x equals 3x minus 9. Okay, solve each compound inequality if possible. Graph the solution set if one exists and write it in interval notation. And this is actually going to be a double inequality. So basically, we're going to substitute all of this in the place of f of x right over here. So we just get -6 less than 3x minus 9 less than or equal to 0. Okay, so we're just putting 3x minus 9 in the place of f of x in that double equality. Okay, now we want to solve for x in the middle. So we're going to add 9 to each end, giving us 3 less than 3x less than or equal to 9. Then we'll divide each piece by 3, 1 less than x less than or equal to 3. So we've solved for x in the middle. We didn't multiply or divide by a negative number, so we don't have to change the directions. Okay. So the graph of that thing, let's see here, 0, 1, 2, 3. Let's see, x is in parentheses there, and a bracket there. And then interval notation would look like that. Okay. Let's see here. How about this one? 3 times the quantity, x plus 2/3, less than or equal to -7, and 2 times the quantity x plus 2 greater than or equal to -2. Be sure that you keep track of whether it's an intersection or a union, okay? A common mistake is people get all the stuff ready and then they do the wrong thing with it. So be careful with that. Okay, let's see. On the left side, to solve that first inequality, I'm going to distribute 3 times x is 3x. 3 times 2/3 would be 6/3 or just 2. So we get that. Then I'm going to subtract 2 from both sides. 3x less than or equal to -9. Divide both sides by 3, x less than or equal to -3. Okay. The second inequality, distributing, I get 2x plus 4 greater than or equal to -2. We're going to subtract 4 from both sides. 2x greater than or equal to -6. Another mistake people make is this is greater than or equal to. Don't let that equal to evaporate. Make sure that you've got the same symbols. Okay. Divide both sides by 2. X is greater than or equal to -3. We're going to bring down this and. So that's what we're going to deal with next. Okay. I'm going to take that and copy it on the next page. X less than or equal to -3 and x greater than or equal to -3. Okay. Let's see, if we graph x is less than or equal to -3, that's going to be what? A bracket at -3 and an arrow going to the left. If we graph x is greater than or equal to -3, we're going to get a bracket on 3 and an arrow going to the right. Okay. Careful. What would the graph of the intersection look like? Now, the typical wrong mistake, I guess that's redundant. The typical wrong answer or mistake is to say, oh, it's all real numbers. No, it's not. We're not talking about the union. Where do these two intersect? At just one point. -3 is all they have in common. Okay. Now, how do you write that in interval notation? It's kind of strange, but it looks like this. So it's the interval from -3 to -3 inclusive. I know that's kind of weird, but that's what that would look like. Okay. I think I have tortured you enough. So before we go, do you have any questions about anything? Over the weekend, you're going to do section 8.3 and 8.4. Monday, we'll wrap up the chapter. And Tuesday, a test. And I know a test every 4 class days. This moves really quickly, but it keeps you from getting bored.
I have a question back on the assignment on part 2 of today's assignment.
Okay. Actually, yesterday's assignment.
Yesterday. Oh, okay. I wasn't here early in the morning in 11, so probably you did. Do you guys did 11?
Let's take a look here. Hang on. Give me just a minute. Yesenia. The reason I corrected you as to the assignment is because the assignment is on the day it's given. Because it's due the next day, I always worry about people that wait until an hour before it's due to work on it. You should be working on it the day it's originally assigned. But anyway, okay. Yesenia, you said which one? 8.2?
The part 11, the temperature.
Okay, but is it 8.2 part 2?
Correct.
Okay, let me find it here. Number 11. Okay, so this problem right there?
Yes.
All right. The temperature in degrees Celsius is equivalent to a temperature in degrees Fahrenheit, or that is equivalent to a temperature in degrees Fahrenheit, is given by the linear function C of F equals 5/9 times the quantity F minus 32, okay? Use this function to find the temperature range in degrees Celsius at which a bottle of cough syrup should be stored. The label directions are shown below. Okay, so it says we're to store it between 77 degrees and, so we'll say between 77 degrees Fahrenheit. Hang on here. And 86 degrees Fahrenheit. Okay. So now what we're going to do is going to go to the whiteboard screen. I need to figure out what 77 degrees Fahrenheit is in Celsius and what 86 degrees Fahrenheit is in Celsius. So I'm going to find C of 77. Okay, going to put the Fahrenheit temperature in for F, which is 5/9 times 77 minus 32. Okay, which is 5/9 times, let's see, 77 minus 32 would be what, 45? Okay. And 45 over 9 reduces to 5 over 1, so that's 25 degrees Celsius. So this is 25 degrees Celsius. So 77 degrees Fahrenheit equals 25 degrees Celsius. Okay so far?
Yes.
All right. Now I need to figure out what 86 degrees Fahrenheit is. So C of 86 is 5/9 times 86 minus 32, which is 5/9 times, what is that, 54? 86 minus 32. 54 over 9 is 6 over 1, so this is 30 degrees Celsius. So, between what two temperatures? Between 25 and 30 degrees Celsius. So we go back to the WebAssign screen, and you see this one in the middle between 25 degrees Celsius and 30 degrees Celsius. Okay with that?
Yes, thank you.
You bet. Any other questions from you or anyone else at this point? All right. Well, then I will stop the recording, and I will see you all on Monday. I'll be back Monday at 10 o'clock with an office hour and 11 o'clock with class. Have a great, safe weekend. Stay cool. Bye now.